Try that on your own. Okay, I'm going to walk through it. So remember the approach to doing stoichiometry. First thing you want to do is the balanced chemical equation. So potassium chloride is heated, decomposes into potassium chloride and oxygen. So the balanced chemical equation should look like that. Right? And this is a place where you can review nomenclature, balancing equations. This is putting a lot of stuff together. So then what we want to do is write the information about each substance by that substance, right? So we're trying to find how many molecules, if you look back at the question, okay, how many potassium chlorate molecules. Okay, we're told about this much about oxygen. We're told that that's the volume, the temperature, and the pressure. So the idea here is that we're going to take this information here, and we're going to use that to get on the mole highway, to get to moles. Then we're going to use the balanced chemical equation to get to moles of potassium chlorate. And from moles of potassium chlorate, we can get to molecules. All right? So I'm going to click this, but you can hit pause in between. All right, so the first thing we have to do is we have to get to moles. So we can use the ideal gas law. PV is nRT. We can solve for N, which is PV over RT. And we were given this information. That's the pressure that was given. That's the volume. That's R. And that's the temperature. Right? We have that right here. And so that means we have this many moles. We're trying to find the number of molecules. So I'm going to do this slowly so you can hit pause in between. So we're going to go from moles of oxygen to potassium chlorate molecules. So whether you work forwards or work backwards, it's kind of up to you. So working backwards, where can I get molecules? I can get molecules from Avogadro's number, right? So now I have moles of KClO3 on the bottom and moles of oxygen. How do I relate those? Well, look at that, a balanced chemical equation. And so I know that there's 2 moles of KClO3 for 3 moles of oxygen. And then we do the math, and there you go. That's how you do it. All right, so the last one. Are you ready? This has got all the teeth. What volume of carbon dioxide at STP will be formed from the reaction of 1.85 grams of calcium carbonate with 50 mils of 0.5 molar hydrochloric acid? All right, so give this a go on your own. Hit pause, try it all by yourself, and then come back to the video, and then I'm going to walk you through it. All right, did you try it on your own? Okay, so let's go through. First thing we need is a balanced equation. Now, in this case, we're told the reactants and a product. We're going to need to come up with the other products. So calcium carbonate, right? Calcium carbonate reacting with hydrochloric acid. Just double check. Yep. All right. So this is double replacement. Now, where does this come from? If you remember, the H will go with the CO3. That's H2CO3. That's one of your decompositions. Now, you may or may not have realized that, but if you wrote H2CO3 here, if the question was asking about CO2, where do you get CO2? Perhaps that would jog your memory, right? Anyway, that's got a decomposition. Don't forget about those. That's why I'm doing this example. Write the information below each substance. So we're told the molarity and volume of the acid. We're told the mass of the calcium carbonate. We're asked about the volume of the CO2. And we're told the temperature and pressure. So, oh my goodness, look at this. Okay, so now we want to get the volume. See if you can tell me something about that question. We want to get the volume. Volume is nRT over P. And look at that. We have R, we have T, and we have P, but we do not have N. So how are we going to get the number of moles of CO2? Well, again, you can always get moles if you know moles of something else on a balanced chemical equation. So let's go over to the right here. To get moles of CO2, see, did you catch it? It's a limiting reactant problem. So let's review this. So what we're going to do once we're figuring out the limiting reactant is we're going to get to moles of CO2, and then we're going to plug the moles in right here. All right, so let's just review limiting reactants. So remember, for limiting reactants, we find out how much of each reactant that we have. So find out the calcium carbonate. Pick one, find out how much you need. And this is the other reactant that I have. So I was told I have 1.85 grams of calcium carbonate. That's the molar mass. Means I have this many moles of calcium carbonate. Told molarity and volume of the hydrochloric acid. So I didn't put an equal sign there, but that's how many moles of hydrochloric acid you have. We pick a reactant, find out how much of the other. So you can see that I chose calcium carbonate. I'm going to need this much HCl. I don't have that much HCl. That means HCl is the limiting reactant here. But now I know the limiting reactant, so I'm going to take the limiting reactant and I'm going to find the moles of carbon dioxide. And that's because that's what I want. I need N. Then I'm going to take this number here and I'm going to put it right there. Just need N. So from the panel on the right, I took the 0.0125 and I plugged it in. And bam, there you go. All right, that's it for this set of slides. So at this point, you should be able to do homework 12. I wish you the best of luck, and I'm available on Zoom as always. Looking forward to helping you guys out. Hang in there.